Morning, Pete, North Las Vegas. Haven't worked on a car for a while. I just don't enjoy being out in the garage when it's in the 30s or the low 40s. But anyway, the weather's starting to warm up here in North Las Vegas, so it's time to get back on the Camaro. I'm to a point now in the engine compartment where I'm ready to start doing some wiring. So first thing I'm going to wire today is the alternator. And then I'll talk a little bit about, why I chose this alternator and how I plan to wire it up. And I'm sure there's many ways to skin a cat, and everybody's going to have a little different way of doing things, but this is how I plan to do it. So I thought we'd start off with the alternator. It's a Power Master. It's a true one wire. You can also wire it up using the CS style plug and use a charge indicator light if you want to. I'm going to be running Dakota instrumentation, and it has a voltmeter, so I won't be using any of the factory wiring for the alternator. And like I said, this is a true one wire, and I was kind of debating on whether I should bother hooking up an extra ground, but I really don't see any reason to. I'm on the side of the alternator case, and so I've already got a very good ground on this alternator, and that's probably mostly for this reinforcement bar that runs down to the headers and the head. Now I may still hook up an extra ground wire just for the hell of it, because that's how I roll. But anyway, I don't really need an extra ground wire, so this alternator will be a true one wire. I got the side mount, which is a 1/4 28. If you get the rear mount style, it's metric, and that comes in at M6 1.0. The back lug here is metric. It's M8.125, and this is what they call their 140 amp or 150 amp. I don't remember. But anyway, here's the specs on it. At idle, it was putting out 107. At cruise, 128, and you got the engine revved up a little bit, 158 amps. And the reason I had to go to this is a GM serpentine belt setup, and like I said, there's the part number for this specific alternator with a left offset, and that dictates on where you're going to mount this part of the alternator to the bracket. So this is left hand, and the reason I had to step it up on my my power is the GM serpentine kit came with a standard 95 or 98 amp alternator, and I'm going to be running twin cooling fans, and I've made some other upgrades and modifications to the electrical system on the car. So I calculated all the circuits, and with everything turned on, headlights, backup lights, brake lights, air conditioning, both fans running, the internal fan for the AC unit, everything you can imagine electrically, I'm going to be running at about 100 amp load. So I mean, with a 100 amp alternator, especially at idle and lower RPMs, you're kind of pushing it. So that's why I decided to step it up with the bigger alternator. Okay, so Power Master is recommending for 100 amps at 8 gauge. You can go up to about 6 feet. For this 140 amp alternator that I'm using, they're recommending 6 gauge up to 6 feet. So I'm planning on running the charge wire down to the starter solenoid, which is less than 6 feet. It ends up being like around 3.5, 4 feet. So I could get away with using 6 gauge, but I've decided, nah, I'm gonna go ahead and step it up. So I bought some sorry about the camera work. I bought some 4 gauge, and you'll see 6 gauge on the left, and that's 4 gauge on the right. So you can see the difference. This is SGX, which has a higher temperature rating than some of the other stuff you can get. And the insulation's a little thicker. It's still relatively flexible, but maybe not quite as flexible as some of the other charging wire that you might use. So anyway, I decided I can deal with the little extra stiffness with the SGX and go with the higher temperature rating. So I don't know if the camera's picking that up, but there's your SAE J1127. So this is rated for automotive use, both these cables. And on the battery cables, I went with the 1127 spec also. I'm going with 2-aught SGX. And this is pretty big stuff. It's the good quality stuff. It's got a very, very high strand count. I mean, this is almost like welding cable. And so that's going to be from the starter solenoid and ground to the battery. And this is the company I've been getting the stuff from. It's I don't have any affiliation with them, so I'm just plugging them because they do sell quality stuff. So anyway, like I was saying, I'm going to go with the 4-gauge charge wire off the alternator and step it up from the 6-gauge that they recommend. And the 6-gauge, honestly, at 140, I'm sure that's plenty. It's derated plenty. You're not going to get any trouble running 6-gauge, but I'm just going to run 4-gauge. And also with the kit, this charging kit came from American Auto Wire, and they used to sell mega fuses at 175 amps, I think they still advertise that on their site. When you order the charge kit from them, you'll get the 6-gauge, but now they provide a 200 amp mega fuse. So this will be going between the alternator and the starter solenoid on the charge wire. So that should be plenty, 200 amps. Okay, so here's some of the hardware I'm going to be using when I do the alternator and battery cable wiring. And I also got this from Custom Battery Cables out of Arizona. Here's what I got from a local shop. And this is brazed. I don't know if the camera's picking that up, but you can see where it got brazed. And it's open-ended, so it's got a little bit more exposure to the elements. And this is what I was originally thinking about using on my starter solenoid. And I decided to go with Custom Battery Cables. They sell a much beefier lug. And you can see the difference, especially in the thickness. And because I'm running, 2-aught battery cable, I decided to go with the heavier duty lug. The issue I ran into is down at the starter solenoid, because this is the dimension that it is, it wouldn't bolt all the way up to the solenoid because of the insulation molding on the solenoid itself at the starter. So what I had to do was I had to build a standoff, and the starter is M8 1.25. It's an MSD aftermarket starter, and I wasn't able to get this on the solenoid because of the insulation. And so what I did was I screwed this onto the solenoid post and gave me a little standoff so I could get the lug away from the starter solenoid. And so that's what this looks like on the starter, on the engine, for the positive battery cable. And I put a washer back here on the car. I just didn't have an extra washer. And then I trimmed the excess off. I left enough to add a couple more connectors for the purple wire and whatever else I might decide to hook up to the battery positive down at the starter. This is tinned copper, and so it's not just a beefy lug, but it's good quality copper. I also bought their battery terminals, same thing. This is all copper. It's not lead like a lot of battery connectors are. And these are all crimps. And well, let's talk about the smaller lugs. This is what American Auto Wire provided, and it's a decent lug. There's nothing wrong with it. But this also came from Custom Battery Cables, and you can see there's quite a bit of difference in thickness and material. And then once again, this is coated pure copper, and so that's kind of the hardware I'll be using. And there's a lot of different schools about whether you should solder or whether you should crimp. And I've decided to go ahead and crimp. So I have this 5-ton crimper. This particular crimper will go from number 12 all the way up to 2/0. So I've decided I'm not going to solder. A good crimp is just as good as a solder joint. And that's what the Navy taught me. And also I hold an airframe and power plant license through the FAA, and they taught us the same thing, that if a crimp is done correctly, it's actually as good as a solder joint, and in some cases there's some advantages to a crimp over a solder joint. So anyway, I know I'm repeating myself. I'm just going to go with crimps on this car. And then yeah, so anyway, I think maybe we need to talk about the alternator a little bit more. PowerMaster says don't spin their alternator up past 18,000 RPM. So I had to do a little math. I measured the crank pulley diameter, and my crank pulley is 7 3/4, and then the alternator pulley diameter on the PowerMaster is 2.375 or 2 3/8. So here's the little formula, and so you're going to divide your crank by the alternator diameter, and you come up with your number. And then you take that number and you multiply it times your expected engine RPM, or you can work the math the other way. You can take your RPM and work it backwards. But anyway, in my case, my pulley diameter is between the alternator and the crankshaft. At 5,500 RPM, I'm going to be spinning at 17,930. Now, this is a ZZ4 engine, so I'm thinking I can probably safely spin it up to 6,000 RPM routinely. How often am I going to be at 6,000 RPM? I don't think I'm going to be putting my foot in it that much. This is not a drag car. It's not going to be a racer. But anyway, if I do get up around 6,000 or whatever, it's like this alternator will be fine, in my opinion. Yeah, so that's where we're at. Like I said, just kind of a quick update video on the Camaro to show what I'm going to be doing today. And yeah, so I'll as I do each electrical section, I'll do another video and maybe create like a playlist, which I'm kind of a lazy YouTuber. I don't edit, I don't dub in music, I don't have any fancy lighting. I use a GoPro. But as I wire up each component on the car, I think I'll do a video. And hopefully maybe that'll help other people out. All right, Pete, North Las Vegas, over and out.